So now let's look again at why RSA is so effective. In the case of the toy problem, we mentioned two possible attacks on RSA. The first was to try and factor the number n into the two prime factors p and q. Of course, in the case we had in the toy problem, it was 33, and then p is 3, say, and q is 11, or the other way around. However, in the case of a 300-digit number, this is just actually not possible with current computing technology. And the security of RSA depends on the difficulty of factoring large n. It's assumed, with good reasons, but not a proof, that there is indeed no effective algorithm, not just that we haven't been smart enough to find one. So the best results so far for factoring large numbers were obtained in 2009 when a 232-digit number, n, was factored. It took the equivalent of 2,000 years on a 2.2 gigahertz single-core computer. Now remember that the number n we had in this example we just discussed was 300 digits. So that means our message is going to be safe for quite a while yet. Also, the number of digits on the average that have been added to the largest number that has been factored has been about 4.5 a year, fairly steadily over the last 30 years or so. And finally, it's worth mentioning in that context that each additional digit does increase the workload by a fixed factor, more or less. The other possible method was to test all w, raise them all to the power e, and see if that gave us c mod n. After all, we know e and we know n, so we just have to check all the w. The problem is there's 10 to the 300 of them in our case, and again, that's not feasible. And in fact, it's believed that the difficulty of this problem, decoding, is equally difficult to this problem, that they're probably equivalent in difficulty and complexity. While RSA cryptography is remarkably robust, there are some security issues that you should be aware of. The first is the importance of padding if the message is short, and secondly, that you need to pad randomly. You certainly should not be using the same padding each time. Another possible attack is to flood Bob's server with many different requests to decode. Now, by measuring the variations in the decryption time for different C, this can give enough information to actually crack RSA. So the point there is that don't implement RSA yourself. You should use good publicly available versions.